Okay guys, we are still doing quadratic functions, but now let's talk about factoring using the quadratic formula. Okay, so last but definitely not least is the quadratic formula. Now another thing about this one is, let's go to red, no restrictions. So this one can always be used when solving quadratic equations, okay? So our steps are write it in standard form. So we know that our standard form is ax squared plus bx plus c equals 0, right? So the first step in using our quadratic formula is that we have to identify a, b, and c, right? These are our coefficients. Please note that they do not have anything to do with our variables, right? It's the number in front of our variables for each of them. So number a is the number in front of x squared, b is the number in front of x, and then c is our constant, okay? Very important. Step 3, we're going to substitute into the quadratic formula what these numbers are. And then fourth, we simplify. So let's talk about what our quadratic formula is. Here is our quadratic formula. X equals negative b plus minus the square root of b squared minus 4 times a times c all over 2 times a. That's our quadratic formula right there, okay? Right there. That is it. Okay, so the radicand is the part that lives underneath the square root. This is the radicand. B squared minus 4 times a times c. Okay, it is also called the discriminant. And it determines the type of solution that we're going to have for the quadratic. So if b squared minus 4ac is greater than 0, another way of saying this is that it's positive, then you will have two real solutions, okay? Okay, and what the two real solutions will look like if it's graphed is something like this. That's not the one I wanted, sorry. Grab the right pen. It's going to look like, we would have one here, one here. Quadratic always graphs like a parabola, like a U or a bowl. So it would look like that. That would be our two solutions, okay? Now let's pick a different color here. So if our discriminant or our radicand, b squared minus 4ac equals 0, then you will have one repeated real number solution. So let's do this one. So if it equals 0, then we're going to have 1 point. It would be right here, and our parabola would touch that point and go up, okay? So that would be our one real solution, where it touches the x-axis. Now, if we have b squared minus 4ac is less than 0, of course this means negative. Then you will have two imaginary real numbers. And this would graph like this. If it's imaginary, it will never cross the x-axis, so it would be more like this, right? It would never cross it, so it would be up here. Okay? Right on. So like I said, here is our quadratic. This is our standard form, as I stated earlier. So looking at this equation, let me change colors so we can kind of blending all together with the yellow. Here is our quadratic function or equation. So we can see that a equals the 2, right? B equals the negative 6. We keep this sign with it. And then C equals the positive 1, or the 1. So then we would take each of these, we put the 2 in place of where the a is, the -6 in place of the b's, and the 1 in place of the c. And then from there it's just kind of plug and chug, which is what I call you just kind of chug along until you find the answer. Okay? So that's how we do the quadratic. So let's do one real quick. First thing we want to do is make sure that it's in standard form. Well, we have ax squared minus bx plus c equals 0, so that is correct. We are there. Next thing we want to do is step 2. We want to identify a, b, and c. So a equals 2, b equals -6, and c equals 1. 3. Now we want to just go ahead and plug this into our quadratic formula. So this is just plug and chug, right? Okay, quadratic formula. X equals -b plus minus square root -b squared minus 4 times a times c, all divided by 2 times a. Hold on. Had a moment. Okay, so x equals -b, but b is our -6, so we need to put that in parentheses, plus minus square root of, well, b is -6 squared, minus 4 times 2, c is times 1, all over 2, and a is 2. Well, negative times a negative is a positive 6, plus minus. -6 squared is going to give us a positive 36 minus 8 over 4. We can keep on working. 6 plus minus. 36 minus 8 is going to give us 28 over 4. We could keep working, but before we do, I need to jump over here and we need to do something real quick. Talk about how we would simplify the square root of 28. When it's like this, we could bust it apart. So the square root of 28, we know that that is 4 times 7, right? So we could say the square root of 4 times 7. We could also break that into the square root of 4 times the square root of 7. That's a legal math move. And we know that the square root of 4 is 2 square roots of 7, right? Because that doesn't work evenly, but this one does. So the square root of 28 equals 2 square roots of 7. So we could rewrite this as 6 plus minus 2 square roots of 7, all divided by 4. Okay, we're almost finished. The only thing that we can do to simplify this anymore, which we always in college algebra want it in the most simplified form, is we can see here that 6, 2, and 4 are all divisible by 2, right? So let's do that. Let's try to find a different color that I haven't used yet. So 2 goes into 6 3 times, 2 goes into 2 once, and 2 goes into 4 2 times. So let's say x equals 3. We don't have to write that 1 because 1 times anything is, well, just anything, right? Square root of 7 over 2. Now remember, in your homework, they're going to want you to write it as 2 numbers. So let's say x equals 3 minus square root of 7 over 2 and 3 plus square root of 7 over 2. If we were to, first of all, find my mouse so that I could pull up my, let's go to y equals, and we could put this in. So 2x squared minus 6x, well, 6x, yeah, plus 1. And then if we graph that, there you go. That is our graph. And that's what it would look like right there. So if we were to say second trace and we wanted to find the 0, so the left bound is just a little bit up over the 0 here. So we hit enter, and then we should be able to go enter, enter. Okay, so that shows us that x equals 0.177. And then if we were to do the same thing, so second trace, go down to 0 and hit enter. Now let's do the second one. So we're going to, let's do here. And then we want to go above it so we can see what that 0 is. Hit enter. And then it asks if we want it to guess, and we're going to say yes. And that's 2.822. Okay, so that's what it gives us for both of those. Now let's get out of that. If we were to say, parentheses, 3 minus square root of 7, oops, divided by 2. Well, that is the exact same number we got for our first bound, right? And then if we were to go up and grab this again, arrow over, make this plus. That was what we got for our second bound. So that's exactly the intercepts that we got. So we're perfect. That's exactly what we wanted. So good job, guys. Okay, let's work this next one. Same steps, right? Is it in standard format? Yes, it is. Then we want to identify, I think that was this color, A, B, and C. So our A is 3, our B is -2, and our C is 4. So now we're just going to plug and chug again, okay? We have the quadratic formula already right there at the top. So x equals -2 plus minus square root -2. Always put it in parentheses, right? Because you want to square that negative as well. Minus 4 times 3 times 4. All that over 2 times 3. Okay, so that's going to equal a positive 2 plus minus, well, -2 squared is going to be 4, minus 12 times 4 is going to be minus 48. All that is going to be over 6. Let's do one more step up here. It's going to be 2 plus minus, well, if we have 4 and we take away 48, that's going to be the square root of -44 over 6. Now we can look and we can see that our discriminant is a negative, right? So we know that that's going to give us imaginary, so we won't cross the x-axis. So then x. So if there's a, remember we've talked about this before, if there's a negative underneath an even root, we have to pull out a what? I hope you said an I, because you're right. Now, we can jump over here and do our light green and figure out how we're going to factor this 44 square root, right? Well, that's 4 times 11, which can also equal the square root of 4 times the square root of 11, and we know what the square root of 4 is, right? It's going to be 2 square roots of 11. Cool, everybody good with that? Go back to the color. Sorry, I almost messed up colors. Coding, that would have been terrible. So 2 plus minus 2 square roots of 11 I over 6. Now 2, 2, and 6 are all divisible. Pink's good. By 2. So it's going to be 1 plus minus square root of 11 I over 3. So we know, since this is imaginary, we're not going to have any intercepts, right? So x is going to equal 1 minus square root of 11i over 3, and 1 plus square root of 11i over 3. Now we can do the same thing we did before and put it in our calculator. Let's do that. So 3 x squared minus 2x plus 4. Let's see how that graphs and see if we're not correct that it won't go across our C. It's way up high, so there are no real intercepts. Okay? Awesome. Now, kind of hit on U substitution earlier. Nope. Sorry, getting ahead of myself. Let's talk about finding the intersection of two functions. So to do that, there's some ways to make it easier. I'm going to show you how to do it by hand, then I'll show you how to do it in the calculator. So to do it by hand, you set the two functions equal to each other. Okay. So after you do that, you want to get it in standard form. So you want it to be ax squared plus bx plus c equals 0. After you get it in your standard form, then you're just going to factor and solve for x. Okay. You substitute the x coordinates into f of x or g of x, doesn't matter which one. Same thing, either way, to find the y coordinates. Okay, and then these are the points at which the two functions intersect. So let's do this real quick, and then I'll show you the cool way that you can check yourself on your calculator. Okay, so we have f of x and g of x, right? So first thing we do is we set the two functions, f of x equal to g of x, okay? But we don't want to just set the names equal to each other. We want to set the value of each one equal to each other. So let's do that. Instead of saying f of x, we want to put the value in. So we're going to say x squared plus 5x minus 3 equals the value of g of x. So that's going to equal 2x plus 1, right? Okay. Now, excuse me. Now we want to get it in standard form, because standard form is like quadratic equals 0. Well, right now it doesn't equal 0, does it? So let's make that happen. Let's subtract 2x and subtract 1. But what we do on one side, we have to do on the other. These two will cancel, so we're going to leave 0 over here. This is going to be x squared plus 3x minus 4. Okay, now we're in standard form. Alright, happy day. Now we can continue on to our next step, which says factor and solve for x. Well, this is something that we easily know how to factor now, right? Factors of 4, opposite signs that subtract to give us 3. Let's look at the factors of 4. 1 and 4, 2 and 2. Which one are going to subtract to give us 3? The larger one gets the plus. X squared means 2x's. Not hard anymore, is it? So we're going to have x minus 1, x plus 4. Now we just have to solve, so let's do that. Move that 1 over by adding it to both sides, so x equals 1. Move this 4 over by subtraction, right? X equals negative 4. Okay, so now we know what our x's are, but we have to find out what our y's are. So this is where it's really cool. Let's pick a green. Green for go. We could plug these points into either f of x or g of x. Doesn't matter. But look which one's super simple and which one's kind of more complicated. So let's plug them into g of x, okay? So we're going to plug or substitute, whichever word you like better, into g of x. So first we're going to have g of 1. So anywhere there's an x, we're going to put a 1. So 2 times 1 plus 1. Well, 2 times 1 is 2 plus 1. That equals 3. So our point, our input, which is always your x, and your output, which is always your y. Beautiful. That's your first point. Cool. Let's do it for the second one. G of negative 4 2 times negative 4 plus 1. Well, that's going to equal negative 8 plus 1, which equals negative 7. So your input was negative 4, your output was negative 7, and that is your second point. And that's all you do. Those are the points at which the two graphs intersect. Okay? Very cool. Let's see what else we got. U sub. See, I knew it was in here somewhere. I was just getting way ahead of myself. Okay, let's talk about it. Some equations are not quadratic, but can be written that way, right? So we're going to use U substitution to make these into a quadratic. Quadratic form also means that it can be expressed as a quadratic with the appropriate substitutions. So, when we use U sub, we always have to make U be a substitution for the more complicated thing in the function. So our more complicated thing in the function this time is x squared, right? So we're always like, well, which one do we make it? Do we make it, I just said x squared now, I meant x plus 2. Do we make it x plus 2 squared, or do we make it just plain old x plus 2? When I was in college algebra, it was kind of confusing to me for a while, but then I figured this out. We always make it the greatest common factor, which is the lowest one, right? The one with the lowest power. So this one's raised to the first power, and this one's raised to the second power. So we have to make it the one that we could factor out. So it's the smaller one. So our U is going to equal x plus 2. Okay? And if it doesn't have a power on the outside, the U doesn't get a power. If it has a power on the outside, the U gets the power. So here we go. When we put the U sub into this, this is now going to be, since U equals x plus 2, we're going to put a U here. Since there's this, I don't want that. Since there's this little 2 right here, he's going to get a 2, okay? So then we're going to say plus, bring this 11 down. X plus 2, well, we know that equals U, so we're going to put a U. But there is no power here, so this U does not get a power. Minus 12. This equals 0. Now we're going to just factor this like we would anything else, okay? So let's do that. Let's just factor. There's 2 U's, right? U squared means, gosh, stop. U squared means 2 U's, so we're going to have 2 factors that equal 0. Okay, we have a negative sign, so that means opposites that subtract to give us 11. So factors of 12, 1 and 12, 2 and 6, 3 and 4. Which of these are going to give us 11? Yes. They're opposites. The larger one gets the plus, the smaller one gets the minus. So minus 1 plus 12. Now we just solve it. U minus 1 equals 0, just like we have all the rest of the time. Add that over. U equals 1. Subtract 12. U equals negative 12. Cool. Now, last thing you have to do. We renamed this as U, right? We have to plug the original name back in. We can't forget that, right? We have to put the original name back in. So instead of leaving it U, we have to put x plus 2 equals 1. And x plus 2 equals negative 12. Cool. Now we have to solve for x, because that's what it originally wanted, was the x-intercept. So let's go. Subtract 2 from both sides. X equals negative 1. Subtract 2 from both sides. X equals negative 14. Alright. So that would be your x-intercepts for the graph. Oops, I didn't mean to do that. Right there. Okay? Let's look at this one. This one's a little bit different, not a lot, but a little, so I tried to pick ones that could be like your homework problems, a little bit different. So on this one, Find the real zeros for the function g of x equals x plus 2 times the square root of x minus 3. So on this one, we're going to look at the square root of x, okay? So let's let u equal the square root of x for this one. Okay, but let's not stop there. If I was to square this side, alright, no, let me not do that. Let's go step over to the side so y'all have both without me messing one up. So let's go this way. What if I take u equals the square root of x, and now, let's do it this way, this is smarter. If I squared this side, what's going to happen? This square and this is going to cancel, right? And that's going to leave me, and then I would have to square this side. So that's going to equal u squared equals x, right? Just by squaring this guy. That makes him be a whole x, which is kind of easier to work with. Okay. So since x equals u squared, we're going to put u squared in place of this guy, alright? So now he is equal to this. And this square root of x is still u. Minus 3 equals 0. Now this is something that you can easily factor. We've been doing this kind of thing for a while now. U squared means 2 u's. Factors of 3. Well, we know he's prime, so that's only 3 and 1, right? This is opposites. That's subtract, so you know it's going to be plus 3 minus 1. Right? Now, set it equal to 0. Solve it. Oops. I started to cut a step out. Okay. But now, we have to plug in our original let x equal. So instead of it be u, we're going to put in square root of x equals negative 3, and square root of x equals 1. Okay, now's when we really have to use our math brain, okay? Because is there anything that we could take the square root of that's going to give us a negative, right? No, right? Because there's no real solution. I can spell solution, because square root of a real number is never negative. Okay, but what about this one? Is there anything that we could take the square root of that would equal 1? Well, x could equal 1, right? The square root of 1 is 1, so that would work. So that would be our answer for that one. Okay, I think that's it, guys. Yeah, that's the end of that one. I'm sorry that one was so long. I usually don't make them that long, so I apologize for that. You guys have a great day, okay?